In the previous episode, From UML Class to Code, I attempt to expose platform-independent modeling so that we can set ourselves up for design and transform to a domain-specific language. So platform-independent model is PIM, P-I-M, and domain-specific language is DSL. I also stated that we do not teach coding in this channel, but I do not want to confuse or mislead modelers who are focused on design. In this episode, we will further explain so that design can be accomplished in a manner that is not disruptive to the project or your developers. With that said, let's preface once again that our focus when doing PIM is design. This should be referred to as high-level design, as more detailed design would be using real software language or code. So with that now said, let's break this episode into two parts for high-level design and detailed design. High-level design, or HLD, is focused on requirements, the nouns and the verbs, where the nouns are your actors, attributes, and variables. I prefer to say data, but you take your nouns any way you want. Verbs are your functions, methods, operations, and processes. In HLD, we're using the requirements to build design that delivers. Detailed design, or DD, is focused on the current code and technology implementation or implementations. This includes code for software and hardware for systems deployment, etc. In DD, detailed design, we're using the code implementations and deployment to design our development and delivery approaches. So when and why to start these approaches? When I stated in the previous episode that I would let developers decide the specific language or technologies to use, I was referring to detailed design and development. During HLD, high-level design, I'm focused on solution architects and enterprise architects, operating at a high level of abstraction during the ideation and requirements engineering phase of delivery. In my world, there are different levels of architects. There's the enterprise architect, the business architect, the solution architect, and application architect, as well as data architect. I tend to think of chief architects differently than enterprise architects, in that the chief architect focuses on the architectural aspects within a specific domain, while the enterprise architect takes a holistic view of the organization's architecture across multiple domains. Both roles are essential in ensuring that the organization's architecture supports its strategic objectives and drives successful outcomes. Chief architects work closely with the application architects, data architects, and developers, while the enterprise architect works closely with business stakeholders and architects respectively. They also work close with solution architects solving the problems of the business for a particular effort. So when to do what? When developing requirements, the solution architect follows the lead of the enterprise architect to produce a solution approach on who does the what. Once a solution has been formed, the solution architect turns to the application architects relevant to the various domains and reaches an agreement on that solution. The solution architect may translate the requirements, the nouns and the verbs, into high-level design, working with application architects, in which those HLDs could be transformed into detailed designs while working with the developers. In the Unified Modeling Language, or UML, especially using Spark's Enterprise Architect, EA, we can model everything from requirements to design and all the project management in between. And we can do this in a common place for the entire team while collaborating along the way. This allows architects to work with all stakeholders in producing models that can be delivered at any time, from ideation to testing to deployment. As we further explain what we're trying to accomplish here, we're going to move from a platform-independent model, this PIM, into a Java, transform this to Java, and actually generate code. We're going to transform the same PIM into a domain-specific language like C#, as well as writing the code either in Sparks or within your IDE. We'll also do the same thing using the same PIM to transform these models into Python. And we will generate code that really works based off of the platform independent model, leading the design based on the technologies that the developers and the application architects wish to implement. All right, let's start building out our design. The first thing we're going to do is bring in a class element, and we're just going to call this rectangle. Then we're going to bring in another class element. We could just hit Control click. It remembers the last thing you did. And we're going to call this one circle. All right. So let's select rectangle first. Let's go ahead and bring our feature window out. I'm just going to set it right here to make life a little bit easier. We're going to start with our attributes, and this is a shape program. So it basically is going to determine the area and perimeter of a rectangle and a circle. So we're going to need length as part of our mathematical equation and width, right? And then for circle, we're going to need radius, right? And then in here, so we've got our attributes. These attributes are integers. No, they're not. These are going to be real numbers because we're going to have decimal places. Now, when we choose a language, a domain-specific language, we will be using the types that language supports. Ultimately, that's double, but we're going to go with real, and we're going to go with real. And when we're looking at the radius, it is not an integer, right? Because we need a real number that's going to support decimals, right? Decimal places. Right, so the next thing is we're going to go to rectangle, go to operations, and we're going to create a method for rectangle, right? And for the circle, we're going to create an operation, a method for circle, right? And we'll get to the things that are on the right here in a moment. But let's just keep going. So we're going to go back over to rectangle, and we're going to have a new operation here, and that's calculate, and then underscore. And then what I'm going to do to cheat a little bit here is I'm going to copy that area, then go down here, and then Control V, calculate perimeter. Right? And then go over to circle. We want to do exactly the same thing. Calculate area and calculate perimeter, right? Perimeter. So hopefully I'm not fat fingering those. First, we're going to do the calculate area, all right? So there's no return type. So we're going to go none, or is it real? It's real, right? Same thing with the return type for perimeter. It is real, right? For this method here, we're going to use none, because what we're doing on the parameters, when we go here, we hit the down arrow, we are going to be looking for length and width as part of our calculations in this method. So what we see here for this method is we have a parameter length, and one for width. There we go. And the return type is what? It is a real number, right? Platform independent. We haven't chosen a language yet. Languages deal with numbers differently. Ultimately, we're going to be using C#, Java, and Python. So we'll be looking at double as the type that's returned, all right? So we see the parameters are length and width for calculating it, calculating perimeter, and calculating area, all right? Same thing applies for circle, right? But the first thing is when we calculate the perimeter, we're looking for real. When we're calculating the area, we're looking for real numbers, all right? And the return type here is none, where the parameters are what? they are radius. See? Length and width, radius, right? And the return type again is a real number, right? There we go. And we've completed the 2 class elements for shape. But we need an interface. So we're going to bring in an interface for both of these. And we're just going to call it I as interface shape. All right, we're going to use that naming convention. And let's go ahead and call out our operations. The first one is, do I still have that? Yes, I do. Calculate underscore area, and then calculate underscore perimeter. All right. And again, I'm hoping I'm not fat fingering those. All right, this doesn't look right, so we made a mistake, and so return type is actually none for this interface because the return types being returned from the class elements have already been defined. All right, so what we need to do is realize these 2 classes. So we're going to draw realization here, realization and realization. Right? Because we're implementing the interface, right? And if we were to look at traceability, we would see rectangle implements the interface. And if we selected interface, interface is realized by the rectangle class and the circle class. Now, depending on how you're implementing this, will determine what other class elements you need to bring in. We're going to be doing a console. So we're going to create a main, a program with an operation in here, simply referred to as main, right? And we're just going to leave it at that for now. We're going to stub this out, and then we'll code it either in Sparks or within the chosen IDE, depending on the DSL, the domain-specific language, chosen during that transformation. All right, in our next episode, we are going to transform this platform-independent model into Java, into C#, and then into Python. So I look forward to seeing you there. And until that episode, happy modeling.